Beneath Japan's storm-tossed seas, where typhoons rage and waves crush steel, trains slice through the darkness, 240 meters below the surface, buried deep beneath the seabed. This isn't science fiction, it's real. The Seikan Tunnel connects Japan's main island, Honshu, and its northern frontier, Hokkaido, an engineering masterpiece buried deep beneath the Tsugaru Strait, built to defy nature itself and link a divided nation. Here's where it all began. Post-war Japan rebuilding from the ashes, engines roaring, factories booming, cities spreading fast. However, one problem remained. Hokkaido, the northernmost island, sat isolated across the wild, icy seas. The only way there? Ferries. And those weren't just inconvenient, they were deadly. The Tsugaru Strait was infamous for brutal winds and raging waters. Then, in 1954, tragedy struck. A typhoon slammed into the region, capsizing the ferry Toya Maru and several others. More than 1,400 lives were lost that night, a national heartbreak. That disaster changed everything. Japan vowed never again to let the sea decide who lives or dies. Engineers, politicians, and dreamers began whispering about the impossible, an undersea tunnel linking Honshu to Hokkaido. By the late 1950s, the idea began to gain real traction. They weren't just planning a tunnel, they were planning to challenge the ocean itself. And this is where it gets crazy. One of Japan's most perilous waterways, the Tsugaru Strait. Honshu's Aomori Prefecture is isolated from Hokkaido's wild shores. Though on the surface it seems lovely, deep blue seas, snow-capped horizons, underneath, chaos reigns. The seabed is unfathomable, the currents are erratic, the winds are ferocious. Soft sediment, volcanic rock, and fault lines throughout, the horror story of a geologist. This was living, moving earth, not merely deep water. The strait had a soul, old mariners used to remark, and it was not amiable. Crossing safely in winter was almost impossible for decades. People called Japan's engineers crazy when they suggested digging a tunnel beneath it. But that is the precise reason they did it. No one else dared to try. This chapter astonished everyone. How do you even begin to arrange anything that has never been done before? Japan's best engineers started exploring the Tsugaru Strait seabed in the late 1950s. Layers of unsteady rock, changing fault lines, and water pressure strong enough to crush steel greeted them. What they discovered was terrible. Still, they persevered. Taking over, Japanese National Railways, or JNR, started years of feasibility studies, testing shafts, and driving meter by meter into the ocean bottom. To investigate water shafts, temperature, and soil movement, every inch was manually logged. They erected pilot tunnels. Approved in the late 1960s, the initiative created the Japan Railway Construction Public Corporation, or JRC, to carry it forward. 17 years of preparation, and they hadn't even begun excavating just yet. The impossible started officially running. And this is where history stopped, breathlessly. Drills finally hit the land under Tsugaru Strait in 1971. The scale was huge, practically scary. Japan invested about 3.6 billion US dollars, around 538 billion yen, in the project. Progress was assessed in meters daily, occasionally just 2 or 3. It was a contest of unrelenting stamina, accuracy, and patience. Floods, gas leaks, cave-ins, the tunnel fought back increasingly as they went deeper. Still, there was no going back. Japan was penetrating history rather than merely excavating a tunnel, and the dream crept closer to reality, 1 meter of rock at a time, with every vibration of those drills. Most people never hear about the human toil, the part the world never sees. For years, nearly 3,000 men lived and worked in darkness, far below sea level. Surrounded by walls that dripped and groaned, they fought tremors, leaks, and the constant roar of machinery. 34 never returned. Quietly, one by one, floods, collapses, and explosions claimed them. With nerves frayed and lungs full of dust, the rest kept pushing forward. Driven more by pride than money, they slept in cramped dorms, cut off from sunlight. One worker's words still echo decades later. We felt its weight every day. even if we never saw the sea above us. It wasn't just construction, it was survival, and in that blackness, these men achieved one of the greatest technological feats the world has ever known. And this is where it gets even more astonishing. The Seikan Tunnel wasn't just hard to build, it was a constant war against nature itself. Beneath the Tsugaru Strait, engineers battled unpredictable fault zones filled with fragile sediment and volcanic rock. The ground changed personality every few meters, solid granite one moment, collapsing mud the next. But their greatest enemy was water. At times, over 400 tons per minute seeped through cracks, threatening to drown everything. The pressure was so immense that a single wall failure could crush a person in seconds. To survive, engineers built three parallel tunnels: the main rail bore, a service tunnel, and a drainage tunnel with powerful pumps running nonstop. Specialized concrete and multi-layer coatings fought off the sea's force, while ventilation shafts pushed life-saving air deep below. Against impossible odds, it worked, an unmatched feat of modern engineering. The tunnel dives 240 meters beneath the sea, the world's deepest railway line. Stretching 53.85 kilometers, it was built with gentle curves and high-strength rails ready for future Shinkansen trains. For years, the underwater Tapikate and Yoshioka-kate stations let visitors explore life below the waves, until 2014, where modernization sealed these rare windows into Japan's most daring dream. Japan commemorated what many consider a marvel of construction: the official opening of the Seikan Tunnel on March 13, 1988. Trains began running between Hakodate, Hokkaido, and Aomori in Honshu after 17 years of construction and incredible challenges. Including the renowned Hokutose and Cassiopeia overnight sleeper trains, the tunnel became part of the Kaikyo line, carrying both passengers and freight. Faster, safer, and far more reliable, the route that once relied on ferries could now be completed in about 2.5 hours. Stations overflowed with people. Live television crews broadcast every moment. Newspapers called it a triumph of human willpower. Japan showed the world that even the ocean could not stand in its way, not just to link two islands, but to unite a nation. For trade and travel, the Seikan Tunnel soon evolved into a lifeline, ensuring a continuous supply even in severe winters. Freight trains started carrying fresh produce, seafood, and industrial items between Hokkaido and the remainder of Japan. Faster delivery and fewer storm-related delays helped local economies, producers, and farmers. Tourism also benefited from the ease of island-hopping travelers could now enjoy. The demand for trains, meanwhile, was swiftly surpassed by the growth of cheap air travel. Many travelers were lost, as flights were often faster and less expensive. The tunnel's attention changed slowly from people to freight transportation to become a crucial alternate route in terrible weather, a silent but important channel in Japan's logistics systems. The Seikan Tunnel is a marvel of precision and safety. Initially built for narrow-gauge freight trains, it now carries the high-speed Hokkaido Shinkansen on dual tracks. Two service tunnels run parallel, linked every 600 meters for quick evacuation. Flame-proof materials, heat sensors, and smoke systems ensure fire safety deep underground. Pressure and temperature are constantly monitored, while pumps remove 20 to 30 tons of water per minute from tiny fractures. Seismic sensors automatically halt trains during earthquakes. Every element, from lighting to communication, is built for reliability. In disaster-prone Japan, the Seikan Tunnel stands as an undersea fortress, a living system that never rests. Almost 3 decades after its glorious opening, the Seikan Tunnel ushered in a fresh era. In 2016, Japan integrated the Hokkaido Shinkansen, transforming this undersea passage into a high-speed railway route. Engineers had to modify the existing dual-gauge infrastructure to allow both narrow-gauge freight trains and standard-gauge Shinkansen to share the same tunnel, a task demanding perfect timing and precision. Inside the tunnel, the Shinkansen's top speed is limited to 140 kilometers per hour, far below its usual 320 kilometer per hour capacity, to prevent dangerous air pressure buildup known as the piston effect. This phenomenon can create shock waves in confined spaces, potentially damaging tunnel structures or affecting nearby trains. Freight and passenger timetables are meticulously synchronized to ensure they never cross paths inside. Travelers on the 25-minute undersea journey experience an eerie calm, soft cabin lights, faint vibrations, and the rhythmic hum of steel on rail. From sleek bullet trains to massive freight, the Seikan Tunnel remains a shared path, a perfect blend of Japan's precision and humility. The Seikan Tunnel still stands distinctively in a world of megatunnels. It is still the longest underwater tunnel on Earth, covering 53.85 kilometers. At 50.45 kilometers, the Channel Tunnel between the UK and France is slightly shorter, but more well known for its cross-border passenger service. Although technically longer at 57.1 kilometers, Switzerland's Gotthard-based tunnel traverses mountains instead of underwater. By contrast, the Seikan Tunnel bears trains below 240 meters of ocean amid great geological instability and water pressure. Among the greats of contemporary engineering, it is unique for its depth and audacity. Japan's strong line cut right across the middle of the sea. Seikan is proof of Japan's bravery, patience, and intelligence rather than just a tunnel. It symbolizes a country rejecting giving in to natural restrictions, a narrative of fortitude engraved in stone and steel. Often dubbed a bridge under the sea, it connects not only Honshu and Hokkaido, but also the spirit of human development across many generations. Freight and emergency logistics still depend on this today, as it silently supports Japan's northern lifelines through storms and earthquakes. For engineers, it's a classroom of creativity. For tourists, a look into the ongoing will of humanity to connect. Every train drifting through its depths whispers the same message Japan delivered to the world in 1988. No distance, no sea, no barrier is genuinely impossible. The Seikan Tunnel never rests, even decades after construction. A complex network of pumps, sensors, and ventilation systems operates constantly beneath layers of rock and sea. Ready to react right away if nature rumbles, engineers always observe seismic activity and structural stress. Every valve, wire, and bolt is checked often and tested. From dual tunnels to backup power, its redundant safety system guarantees the line stays safe even in difficult situations. The Seikan Tunnel saga is still ongoing. By 2031, the Hokkaido Shinkansen could extend all the way to Sapporo, therefore establishing a continuous Tokyo to Sapporo corridor spanning about 1,100 kilometers of high-speed rail. This will significantly reduce travel times, therefore boosting regional development, commerce, and tourism. As Japan's northern lifeline, the tunnel will be vital to guarantee dependable transportation even during extreme weather or crises. The Seikan Tunnel isn't just concrete and steel. It's proof of what human courage can achieve when faced with the impossible. It's a bridge beneath an ocean, born from tragedy but built on hope. So, what do you think of this engineering marvel? Like, share, and subscribe for more incredible stories ahead.